Hello everyone, welcome back to my YouTube channel. This is Harshita, pursuing my degree in SVC Bangalore, fourth semester CSE department. Today we are going to learn about correlation and regression. So contents are definition of correlation, definition of regression, types of regression, some formulas, example and conclusion. So coming back to correlation and regression are two statistical method concepts are commonly used to analyze the relationship between variables and make predictions. Moving on to definition of correlation. Correlation measures the strength of direction of the linear relationship between two or more variables. It does not imply caution but helps to identify if there is constant partner between the variables. Moving on to types of correlation. Pearson correlation. The Pearson correlation coefficient is the most common method to measure the correlation between two continuous variables. It ranges from -1 to 1. The positive value indicates a positive correlation. Both variable increases together. The negative value indicates negative correlation. One variable increases while the other variable decreases. And the value is close to 0 indicates a weak or non-correlation. Moving on to second type, Spearman rank correlation. This method measures the strength and direction of monotic relationship, not necessarily linear, between the two variables. It is used when the variables are ordinal or the relationship in non-linear. Candle-star relation. Similar to Spearman rank correlation, K measures the strength of ordinal association between. Moving on to definition of regression. Regression is a statistical technique used to model the relationship between a dependent variable and one or more independent variables. The goal of regression analysis is to find the best fitting mathematical equation that describes how the independent variables affect the dependent variables. There are various types of regression, but the two main categories are simple linear regression. This type of regression involves a single independent variable and a single dependent variable, and the relationship between them is assumed to be linear. The equation for a similar linear regression model is in the form of y is equals to mx plus b, where y is dependent variable, x is independent variable, m is a slope, the rate of change of y with respect to x, and b is y-intercept, the value of when x is equals to 0. Multiple regression is a statistical technique used to explore the relationship between a dependent variable and two or more independent variables. It extends the idea of simple linear regression, which involves finding a relation between a dependent variable and single independent variable. In multiple regression, we have one dependent variable and multiple independent variable. Moving on to coefficient of correlation definition. The coefficient of correlation, also known as correlation coefficient, it is a statistical measure that quantifies the strength and direction of linear relationship between two variables. It is denoted by the symbol R and can range from -1 to 1. If the correlation coefficient is +1, it indicates the perfect positive correlation, meaning that as one variable increases, the other variable also increases in a linear fashion. If the correlation coefficient is -1, it indicates a perfect negative correlation, meaning that as one variable increases, then the other variable decreases in a linear fashion. If the correlation coefficient is close to 0, it indicates a weak or non-linear relationship between two variables. Now moving on to some list of formulas are regression of line x on y is equal to x minus x bar is equal to r into sigma x divided by sigma y into y minus y bar. Regression line of y on x is denotes as y minus y bar is equal to r into sigma y divided by sigma x into x minus x bar. Regression coefficient of x and y is equals to plus or minus root coefficient of x and coefficient of y. Correlation coefficient is equals to R is equal to summation x minus x bar into y minus y bar divided by n into sigma x into sigma. So based on the formulas, we'll see one example. Find the correlation coefficient and regression line of y on x for the following data. Estimate the value of y when x is equals to 0. Here the values of x and y are given. X is equals to 1, 3, 4, 6, 8, 9, 11, 14. Y values are 1, 2, 4, 4, 5, 7, 8, 9. So for estimating, the formula is given. R is equals to summation xy divided by n into sigma x into sigma y is equals to summation x minus x bar into y minus y bar divided by n into sigma x into sigma y. To find all these values, we have to put a table. We have to put x values, y values. Capital X is equals to x minus x bar. Capital Y is equals to y minus y bar. X square, y square, x into y. X values are 1, 3, 4, 6, 8, 9, 11, 14. By adding all this, we'll get summation x is equals to 56. Y values are 1, 2, 4, 4, 5, 7, 8, 9. By adding all this value, we'll get summation y is equals to 40. Now we have to find capital X value. Capital X value is equals to small x minus small x bar. Where 56 by n is equals to 8. 56 by 8 is equals to 7. 1 minus 7 is equals to minus 6. 3 minus 7 is equals to minus 4. 4 minus 7 is equals to minus 3. 6 minus 7 is equals to minus 1. 8 minus 7 is equals to 1. 9 minus 7 is equals to 2. 11 minus 7 is equals to 4. 14 minus 7 is equals to 7. To find capital Y is equals to small y minus y bar, where 40 by n value is 8. 40 by 8 is equals to 5. 1 minus y is equals to minus 4. 2 minus y is equals to minus 3. 4 minus y is equals to minus 1. 4 minus y is equals to minus 1. 5 minus y is equals to 0. 7 minus y is equals to 2. 8 minus y is equals to 3. 9 minus y is equals to 4. So now we have to find x square value. 6 square is 36. Minus 5 whole square is minus 4 whole square is 16. Minus 3 whole square is 9. Minus 1 whole square is 1. 1 square is 1. 2 square is 4. 4 square is 16. 7 square is 49. By adding all this value, we'll get summation x square is equal to 132. Now we have to find y square value. Minus 4 whole square is equal to 16. Minus 3 whole square is equal to 9. Minus 1 whole square is equal to 1. Minus 1 whole square is equal to 1. 0 square is 0. 2 square is 4. 3 square is 9. 4 square is 16. A summation y square is equal to 56. By adding all this value, we get summation y square is 56. Now we have to multiply this capital X and this capital Y. Minus 6 into minus 4 is minus 24. Minus 4 into minus 3 is minus 12. Minus 3 into minus 1 is minus plus 3. Minus 1 into minus 1 is plus 1. 1 into 0 is 0. 2 into 2 is 4. 4 into 3 is 12. 7 into 4 is 28. So as we have discussed, that is x bar is equal to summation x by n is equals to 56 divided by 8 is 7. Y bar is equals to summation y divided by n is equals to 40 divided by 8 is equals to 5. Sigma x square is equals to summation x square is equals to 132 divided by 8, that is 16.5. By doing this root of 16.5, we get sigma x, that is 4.06. Sigma summation y square is equals to sigma y square, it is equals to 56 divided by 8 is 7. By doing square root, we get some sigma y, that is 2.646. R is this all values you should substitute in the formula. R is equals to 84 divided by 8. into 4.06 into 2.646 will get R is equals to 0.977. Regression on line of y on x is equals to y minus y bar is equals to R into sigma x divided by sigma y into x minus x bar. At in the question they have given as at x is equals to 10. So y minus 5 is equals to 0.977 into 2.646 divided by 4.06 into 10 minus 7 will get y minus 5 is equals to 0.977 into this this and this we have to divide 0.652 into 10 minus 7 is 3. We have to multiply this 0.977 into 0.652 into 3 will get y is equals to 6.911. So moving on to our last conclusion. In conclusion, the correlation and regression are powerful statistical techniques used to analyze the relationship between variables in the data set. They are essential tools in both descriptive and inferential statistics, helping researchers and analysts to understand and model to the associations between different variables. So thank you for watching. Please do like my video, share my video and subscribe to my YouTube channel.